new problem. I'm going to do the one that I assigned as a homework problem for production.
You're the best.
So this way you can compare my answers with yours. So let me give you the preview and then we'll do the problems. For this one, production planning, as I said, there are only two plans that I'm going to ask you questions for. In the matching plan, we produce always equal to the demand, and the only cost we incur is hiring and layoff cost, because we keep on, since we produce equal to the demand changes, our production changes. So our workforce changes. So we're continuously hiring and laying off. So the total cost of that one is hiring and layoff cost. The other plan is the levelized plan, where we produce at a steady rate. If the production rate is steady, our workforce is steady. So there is no hiring and layoff. But in this case, while we make up for the fluctuations in the demand by inventory and back ordering. So in that case, we have back order and inventory cost. So to make the long story short, matching plan is equivalent to hiring and layoff costs. Levelized plan is equivalent to inventory and back order cost. So let's do it now. So matching plan, what is the idea? Matching plan, demand matches the production. Production matches the demand. Levelized plan, production is stable. It's the same. And we keep on having shortages, which is back order, or surpluses, which is inventory. So again, to facilitate the doing the numbers, I prefer to do the problem that I assigned. So this way, you have an opportunity to compare answers.
I think like for maximum reinforcement, the same problem should be on the test.
No, the same wording. No, don't take it. The same wording of the problems will be on the test with different numbers. Okay. That I can tell you. The same wording. Because I don't want you, if I change even the wording, some of you may say, well, it's a trick here. The wording will be the same. The numbers will be different, but the wording will be the same. So this way, for example, in this problem, what is the wording? First question, what is the total hiring and layoff cost for a matching plan? Then the wording for the second problem, what is the inventory and back order cost for a levelized plan? So the wording will be the same. What is going to be different is the numbers. Okay, let's start with the first one. So the first one was the problem.
Number two.
Yeah,
I'll read it to you, Professor.
No, I have it here. Just give me a minute to locate it.
No, thank you.
You need 2, 3, and 4.
Okay. Number 2, it says, actually it was problem 3. Use the same data as in exercise 2, but use hiring and layoff costs at 30 each to chase demand. So I changed the wording a little bit. And I said we have a demand pattern, 1, 2, 3, 4 quarters, and we have demand. So the data, it was from the previous problem, 40, 60, 30, 40, 60, 30, 20. 40, 60, 30, 20. We also need to know the initial conditions. So the initial conditions was 2 workers. And the productivity was 10 units per worker. Per quarter. Okay, hiring cost. $30 per worker. Layoff cost. $30 per worker. Okay, so that's how the problem about, so the question here, the question is the following. What is the total annual hiring and layoff cost for a chase demand? This plan has 2 names, either chase demand or matching plan. Both are synonyms. They mean the same thing. We can call this plan either a chase demand plan or a matching plan. So the question is, what is the total annual hiring and layoff cost for a matching plan for this problem? Information. It's either matching, chase demand. It's the same. It's synonyms. They mean the same thing. What type of information do we need? We need to know how many workers we have at the beginning. We also need to know the productivity. In this case, the answer is 2, given. We also need to know the productivity rate. How many units each worker produces per quarter? So the value here given to us is what? 10. So 10 units, each worker is capable of producing 10 units per quarter. The next piece of information, of course, is the cost. What is the hiring cost per worker? In this case, 30. And what is the layoff cost per worker? In this case, also 30. It's a coincidence that both numbers are the same. They don't have to be the same. And the final piece of information, of course, that we need is what? The demand. So the demand will be given on a quarterly basis. Okay, so how do we solve this problem? So the first thing is we're looking and we say it's a matching or chase demand plan. So production is equal to the demand. The demand is also production because that's the definition of the plan. Each quarter we produce exactly what the demand is. So there is no need to replicate the demand, to replicate this column and write a production column which will be identical. We say P equal P. In this works only for matching plan. For a matching plan, demand and production coincide. So then what we need to know, in order to produce those units, how many workers do we need in each one of the 4 quarters? Or in each one of the 4 quarters? So we come up with a new column, workers needed. So here, for each quarter, we have to fill in a number. How many workers do we need?
4.
How do we figure it out? We always use the demand against this. That's the reason we have to know how many workers, how many units each worker can produce. For example, in the first quarter, we need to produce 40 units. Each worker is capable of producing 10. That will be given. So how many workers do we need? 40 divided by 10. So this is the number that is going to enable us to convert the demand into how many workers we need. If each worker is producing 10 and we need to produce 40, how many workers do we need in the first quarter? 4. 40 divided by 10. Next quarter, 60 divided by 10. 6. Third quarter, 30 divided by 10. 3. Last quarter, 20 divided by 10. 2. So the number of workers needed is always determined by dividing the demand by the productivity rate. That means by the number of units that each worker can produce. So in this case, we divided all the demand numbers by 10. And that gave us the number of workers we need in each quarter. Now we need 2 more columns. We need to figure out in each quarter if we have to add or to subtract workers. So actually we use formal terms, 2 additional columns. So one column here is workers hired. And the next one next to it,
Fire.
workers laid off.
5.
No, there is a difference between the two. As you know, it's a legal difference. I mean, if somebody is fired, it's for cause. If somebody is laid off, it's not for cause. So that makes a big difference when there is arbitration. If somebody is told that you are dismissed, they don't use fire on papers, that implies cause. If somebody is being told you are laid off, it doesn't imply cause. It means that it was redundant. But as far as the standing of the worker is good. And why is that significant besides the legal difference that I just told you? It's also important when the company rehires. If the company rehires, by union rules, it's last out, first in. That means the ones who were laid off last is the first one to come back. So if companies, big companies lay off workers, let's assume they lay off somebody in January, February, March, April. And then they say, oh, new order, we have to start rehiring in June. You rehire the last one you laid off. Yeah. So that's the reason those terms, you need to be careful. I mean, we use it in day-to-day conversation. This person got fired. But legally, if that is the case, that means it was cause. That this person did something and the company decided that they don't want it. But if the person is laid off, there is no cause. It was just redundancy. That the productivity, the company needs fewer employees, so they have to lay off. But that is important, even the timing, as I told you. Because if they start rehiring, by law, they have to rehire the last one they laid off. And if they keep on hiring more, they go back and back and back and getting them back.
But laying off employees, does that, like, how do you base
In real life, you mean, how it works. Okay, first of all, when they say layoff, it's sometimes they clearly specify, like in this case, the layoffs are temporary because they're based on the seasonality of the demand. So in that case, sometimes they even tell them for how long they're being laid off. And they say they are putting on suspension, suspended is not a good word. So sometimes they said you're putting on hold or something like that for a given time period. But these are usually during the layoff period. If it's temporary, there are two also important points to be taken into account. First of all, they retain some type of wages. They don't get zero, they get something, a type of severance pay. And in some corporations, big ones, they retain part of the benefits, which is more important. So that's the reason those terms are important. Those terms are important, especially if it's done, as I said, when the demand is seasonal. Many corporations face seasonal demand. So this is, like in this case, if that pattern repeats next year, then these people know when they go in and out. So anyway, for our purposes, it's just a number. So now, what is the next thing to do? The next thing is that I want you to be very careful when I do it. Because the best way to understand, again, is visually. So when we started, there was a number here, 2 workers. So the number we put, first of all, as I said, one of the 2 numbers will always be 0. That means when we start, if we need more workers, we hire. If we need fewer workers, we lay off. But we don't hire and lay off at the same time. One implies we need more, the other one implies we need less. We cannot need more and less at the same time. So when we start, at the beginning of each quarter, one of the 2 numbers will be always a 0. Maybe both zeros in some extreme case, but at least one of the 2 is a 0. So when we start, look at the number. So it's always comparison, what we have versus what we need. So when we start, we have 2, but we need 4. If we have 2 and we need 4, what we need to do? Add, higher. So 2 higher. And of course that becomes a 0. So now, move up 3 months. End of first, beginning of the second quarter. We have 4, but we need 6. It's always the current one versus the previous one. So look at where I am. Look at where I point at. Beginning of the second quarter. We need 6. But what we end up the first quarter with 4? What we end up the first quarter with? 4. So we end up with 4, we need 6. We need 2 more. So 2 more here. So no layoffs. Fast forward 3 months. End of the second, beginning of the third. We end the second quarter with 6, but we need 3 at the beginning of the third. So we end with 6, we need 3. 3 have to go. So lay off 3. Again, move on 3 more months. End of the third. We end the third quarter with 3, but we want only 2 at the beginning of the fourth. So we end with 3, we need 2. 1 has to go. So 1 has to go and 0. Okay, where is this coming from? Because there is here it said 2 workers at the beginning. That's where it came from. I will give you an initial number. That when we start, we have X workers. So when we started, this problem said we have 2. So that's what I used to determine how many I need. So I start with 2, I need 4. So 2 more have to add it. Okay, please understand how it works. It's always the previous with the next number. If you understand the mechanics of it, the previous with the next number, the rest is easy. Okay, so now, after that, it's just cost calculations. So now we have the numbers. For the full year, we have the total number hired and laid off. So what is the total cost of this plan? As I said, the total cost of this plan is the total hiring cost for the year plus the total layoff cost for the year. So in that case, again, it's a coincidence. We add up for the year 4 and 4. They don't have to be equal. In this case, they happen to be equal. They don't have to be equal. So what is the total annual cost? For the hiring is 4 hired times 30 because of this, plus 4 laid off times 30 because of this. 240 per year. Okay, so that's the answer to the question of what is the total annual cost of a matching or chase demand plan. The annual cost of a matching or chase demand plan is the total annual hiring and layoff cost. Again, as I said, the key step here is what I did when I fill in those columns, the hiring and layoff columns. It's always comparing what we need versus what we have. So as we move on from one quarter to the next, we have to adjust. If we need, in the next quarter, if the number is higher, we need more, we hire the difference. If we need fewer, we lay off the difference. All right, let me do the other half. And then the other half is if we have a levelized plan. So I gave you a different set of numbers. So right now, I'm going to keep that over there so you can see it for some time. So let me work for the other one now.
So the one we just did is matching.
So what we did now is a matching or chase demand. Sometimes it's called chase demand, sometimes it's called matching. Chase like I'm chasing somebody. Let me write it.
Oh, chase.
Chase, sorry.
So the question would be what is the hiring and
A layoff cost for a matching or chase demand plan. Chase because I'm chasing. It's like chasing somebody.
You're chasing the demand.
It's chasing the demand, exactly. Because the production is matching, it's like chasing the demand. But the more formal name is matching plan. That the production is matching the demand. Both of them, as I said, are synonyms. They mean the same thing. Again, I will say in the exam, even if I use either one of those names, that the cost is hiring and layoff. That will be the key. That what we have to do is to adjust the workforce that determines hiring and layoff costs.
So in this example, they need $240 a year to cover the hiring and layoff.
To carry, what is the interpretation of this number? It's the total hiring and layoff cost for a full year. Okay, let's do the rest. Let's do the next one. So the next one is a levelized plan. So let me read the data from the next problem. Problem number 4. Find the cost of inventory and back ordering with level production to meet quarterly demand, so different numbers now. So let me put the demand per quarter. So the demand is 20, 50, 30, and 40. And here we have two costs. Inventory cost, $10 per unit per quarter. And we're also given back order cost, $15 per unit per quarter. Okay, so this problem will read as follows. Given this demand pattern and the inventory and back order cost that's on the board, what is the total annual cost of a levelized plan, which is equivalent to saying what is the total inventory and back order cost for a year of a levelized plan. So the first computation that we need, if we're dealing with a levelized plan, is to figure out what is the production rate. The production rate is the same. So since it's the same, so here I need a new column, production. The production rate is the same. So since the production rate is the same for each quarter, it has to be equal to what? The average demand. So the production rate is the average of those numbers. So let's figure out the total here is 140.
26.
So the production should be equal to 140 divided by 4 because it's 140 per year. So if we divide by 4 to figure out the production per quarter, 35. So that's the first computation. The first computation is to determine what is this average production rate, which is the same throughout the year. So let's put the 35 there.
35 is the average production rate.
35 is the production rate, which is, let me phrase it better, it's the production rate, which is equal to the average demand. So it's the production rate, which must be equal to the average demand. Okay, so in this case, as I said numerous times, we don't have hiring and layoff issues. What we do is we have fluctuations between production and demand. Those fluctuations, what do they generate? Inventories or back orders? We have an inventory at the end of the quarter if we have more units at the end than the demand. And we have a back order if we have fewer units. So how do we proceed? We proceed by creating 4 additional columns. So we have a column to report the beginning inventory, another one the ending inventory, the beginning back order, and the ending back order. So again, in this problem, we have 4 additional columns. BI is beginning inventory. Always, when we start with a 0. So that means there is no units already produced from a previous assignment. So we start with a 0. We also have a beginning back order of 0. That means there are no prior commitments. Back order is a commitment. So when we start clean. We have no prior commitments. That's the reason beginning back order for the first quarter is 0. But we don't have inventory accumulated from other actions. So beginning inventory and beginning back order for the first quarter is always equal to 0. And then how do we, what is our obligation? To figure out, look at the question mark, to figure out what will be the inventory at the end of the first quarter. Someone's going to say, and this one, yes, but if we know this, we know that. Why? If we have an if we figure out the inventory at the end of the first quarter and it's positive, that means there is no back order. If we figure out this number, it happens to be negative, minus 10. Let's assume it's minus 10. Obviously, that is a shortage of 10. So if it's a negative inventory, what do? We put a 0 for inventory, and that amount becomes what? A back order. So here is the rule. We don't need a separate formula for back orders. We have a formula, which I'm going to write on the board. Some of you ask me, do I have to memorize? No, I'm going to write this on the board next week. So we have a formula, which I'm going to write on the board, and that formula is used to determine the inventory at the end of the quarter. Do we need a separate formula for back orders? No. Why? Because if that inventory is positive, 10, 20, 30, there is no back order. If that inventory is negative, that quantity, it automatically becomes a back order. So this is the rationale. One formula for inventory. That formula serves indirectly as a formula for the back orders. Why? Because if it provides a negative value, that quantity becomes a back order. So the formula, because some of you said, I don't want you to worry about memorizing. No memorization. I'll write it. But I want you to understand the rationale of the formula. So the formula works as follows. What we have at the end equals what we have at the beginning plus what we add. Remember how we add through the production process. Minus what we take away. We take away to satisfy current demand and also prior demand. So the formula is as follows. Not, as I said, I'm going to write it. So it reads as follows. What we have at the end, ending inventory, is equal to what we have at the beginning inventory, plus what we add, the production, minus what we take away. Why are we taking away units? For 2 reasons. To satisfy current demand, minus D, and also to satisfy prior commitments, minus beginning back orders. So that's how the formula reads. So let's implement this formula for the first quarter of this year. So let's implement it. So when we start, beginning inventory 0, plus production 35, minus demand 20, minus back order 0, 15. So a positive number. Since we ended up with a positive number, the number here is positive, so there is an inventory. If it's positive, there is an inventory. But what does it mean for back orders?
No.
0. Exactly. A positive inventory means no back order. Let's assume it was negative 15. I would have put what?
0.
If it was negative 15, 0 for inventory, and that would have become a back order. So that's just to understand it. If it's positive, it's inventory. There is no back order. If it's negative, shortage. 0 for inventory, and that amount is back order. It's a shortage. Inventory means surplus. Back order means shortage. That's how, just think about it with words. Inventory is a surplus. So I have a surplus of 15 units.
So beginning inventory will be 15.
Let's assume it was negative in 15 for inventory. We did that, it was negative 15. Means a shortage of 15. I would have put 0 for EI, ending inventory, and 15 for ED, ending back order. If it were negative, 0 for inventory, I would put it in the back order column as an ending back order. Okay, so that's half the story. What else do we need to finish it? Continuity. The ending inventory of the first becomes beginning of the second. The ending back order of the first becomes beginning back order of the second. So the second rule is continuity. Things flow. So the ending inventory of the first becomes beginning of the second. So let me look at the arrow. That value moves here. And the ending back order of the first becomes beginning back order of the second. Another arrow. So you see how things are moving down. Ending quantities of the first become beginning quantities of the second. Where is the question mark now? The question mark is here. So now I'm asking myself, what is the ending inventory of the second quarter?
0.
So, in this case, it's an ideal situation. Let me do the numbers. So the ending inventory of the second, again, formula doesn't change. Formula is the same. Beginning, which is 15, plus production, which is 35, minus demand, which is 50, minus back order, which is 0. 0. That's an ideal situation. No shortages, no surpluses. So 0 inventory, that means back order will also be 0. So if you are the manager, that's what you want to see at the end of each quarter. Just zeros. So you don't have to carry forward anything, but you don't have a shortage. So that's ideal. So that's not happening too often, but as I said, this is an ideal situation. 0, 0. Okay, so now you get the flow of it. Ending of the second, ending inventory and ending back order of the second become beginning inventory and beginning back order of the third. So that 0 is going to move here. And this, the back order 0, is moving there. Here is the question mark. So the question mark now is what is the ending inventory of the third quarter? So I'm going to do it all over again. So the ending inventory of the third quarter is going to be the beginning, which is 0, plus production, which is 35, minus demand, which is 30, minus back order, which is 0, 5. Again, there is an inventory. 5 is positive, it's more than 0. So that means no back order for the third quarter. The ending back order of the third is 0. Whenever there is a positive inventory, more than 0, obviously, there is no back order. And now the final step. In this one, again, we carry forward, so the 5 ending inventory of third becomes beginning of the fourth, and the 0 back order of the third becomes beginning of the fourth. And the question mark, what is the ending inventory of quarter 4? If we do it right, now that's a mathematical result. The ending inventory of the last quarter should always 0, which implies, of course, that the back order is 0. If it's not 0, something is wrong. Something is wrong. Why? Because how was 35 computed? Look at the 35. The 35 was computed, so total production is equal to 140, which is the total demand. So if total production is equal to the total demand, starting with a 0, things are going to even out. So we're going to end up with a 0. We must end up with a 0. So that's the reason I said that the ending inventory of the last quarter has to be 0. And of course, that automatically implies that the ending back order of the last quarter is also 0. So let's do the numbers to verify that. But we know that beforehand. We have to end up with a 0. So, beginning inventory of the fourth, look at the numbers. I'm looking here. 5 plus production, 35, minus demand, 40, minus 0 back order, 0, as expected. 0, 0. Okay. So here there is again a check and balance. We know beforehand that if we do it right, we have to end up with 0 inventory for the last quarter, which automatically implies also a 0 back order for the last quarter. So we're down to what now? Computing the cost. So what is the cost for this problem? Two costs, inventory cost and back order cost. So which values do we use to determine the cost? The ending inventory for inventory, and these values for the back orders. So for inventory, we have 15 units at the end of the first quarter, 0 at the end of the second, 5 at the end of the third, 0 at the end of the fourth. What is the charge? $10 per unit per quarter. To shorten up the calculations, I can add up those numbers. Let's add up each one of the column, the values in the ending inventory. Add them up. It's 20 total, and a 0 here. So the total cost will be 20 units throughout the year, but each one of them was held in inventory for how long? 1 quarter. So the charge is 20 times 10 plus, on the back order column, it's a 0, but let me put it just to know, 0 times 15, 200. So in this plan, as I said, we have inventory and back order costs. So on the inventory cost, when we're done, since the charge is per quarter, as a shortcut, I added them up. I added up all the ending inventories. By adding them up, I save time. If you don't want to add them up, you have to do it one at a time. 15 times 10 plus 0 times 10 plus 5 times 10 plus 0 times 10. By adding them up, I just do a shortcut, 20 times 10. Plus whatever is here, in this problem happens to be 0 times 15.
Well, for the formula, we will use beginning inventory.
Always, we use for the computations, we use ending inventories and ending back orders. That formula I will write on the board next week, so you don't have to memorize.
Thank you, Professor.
So that formula applies to the levelized plan. Always be 0. So I will give you, I don't want to complicate things. That's why some of you said, are you going to make changes? No, I do not intend to make any changes.
Even the problems? So
So in this problem, you will given, just take a snapshot of this, you will given exactly the same information. Let me repeat the information. For the matching plan, hiring cost, layoff cost, how many units a worker produces and how many workers we have at the beginning. For the levelized plan, 2 pieces of information. Inventory cost, back order cost. That's all you need. Of course, the demand. Okay, again, I know we're taking too many short breaks, but I want you to have an opportunity to rehash. So 5 minutes. Let me put the check mark now there, and we come back with the linear programming. So 5 minutes.
Which one?
First one, but I'm here.
Oh.